All right. I want to do a quick 30-minute stream on doing a little bit of work on Relayscan. Relayscan is the website that shows the MevBoost ecosystem, the relays, the builders, inclusion rates, profitability, or some time ranges. And it also has a historical stats view. Let's see, it's on GitHub Relayscan. And here's more information. Stats day. This is, so that would be day something. You can see the stats for some other day. What I added recently was a PR that does bit collection across all relays. This is very similar to Mempool Dumpster. Mempool Dumpster is a service to collect mempool transactions and then upload it and share it. So Mempool Dumpster is also an open source project from Flashbots. Here you can see the code. And what it does, it's basically collector instances that write to local CSV files, and then once a night they get combined, a little processed, and then uploaded to R2 and S3. And then this has a website generator. So back to Relayscan. Relayscan does have bit archival now. So there's also a collector that, let's open ColleDraw. There is a collector that receives bits from various sources. One of these sources is get header requests. One of these sources is data APIs. And one of these sources is the ultrasound relay top bit stream. All right, so there is a PR open here and more information in this document. I think I want to clean up this document as one, and there's additional links. So let's start with the document. I have the Relayscan code base open here. And I started this as like an ADR initially, but I think we actually want to move this to just a document that's more of an oral description instead of an architecture decision record. So I think what I'm going to do is I create a new doc. Let's say 2406 bit collect md, make a new file and then delete the old one. So let's see. Let's do this first. And it's also useful to get a bit of an overview. Let's see, this is bit collection. Goal, collect all bit. Relayscan should collect bits across relays. Let's see. First, get header polling, data API polling. Then let's open the builder specs, and that we can add the appropriate links. The builder specs is the MevBoost specification, basically, which is here, and the get header request is this one. We add this here, and then there is a relay specs on GitHub to get the additional data APIs. Big shout out to Justin Traglia who helped set this up. And there is a data API on the relays that allows to get the bits for any given slot. And lastly, there is the ultrasound top bit WebSocket stream. And all of these free options have some caveats. Let's see, output, CSV file archive, and second, maybe a stream. That's not really required for now. Then let's do some notes on data sources. There is these source types. Let's do it like this. Have different limitations. Get header polling, and I think the plugin takes the information from the left. Some really only allow a single get header request per slot. So on get header, some release just allow one per IP per slot. So we do this and we time it currently at 1 second, I think. And the header has all the limit information, no optimistic field, no builder pub key field, and not any included timestamps. And the ultrasound WebSocket stream. Let's see, the second one is the data API polling. Has all the necessary information. Due to rate limits, we only poll at specific times. And these specific times, they are currently these times. Let's double check that with the code. So the code base here, all the code is in services bit collect. And I think we look at the data API poller, for instance. That's the code that polls for data API, and here is actually the timing -4 or -2, -0.5, +0.5 and 2. That's correct. See also services bit collect data. Can we actually make this like a internal relative link? No, I think not. Maybe on here. Copy relative path. Data API polar.go. Let's see if that will work. Then we say manual, give it the number 64 to 69. Okay, let's see later if this works. And the ultrasound WebSocket stream has other. The limitation here is that it doesn't expose the optimistic field, so it's always false. Okay, that's an important documentation on the caveats. Running it. So I can talk a CSV or TSV output, but that doesn't really matter so much. Let's say data API dash dash. Okay, let's look this actually up. There is a core service bit collect, and that has these flags. So it's like bit collect data API, get header, ultrasound stream, and you want for, okay, let's remove the get header because that has additional requirements. Let's get to that in a moment. And data API and ultrasound stream, all the subscription, like that doesn't need any external services. The get header request does need a CL client to get the slot information. And you can do all relays. Okay. Okay. Get header needs a beacon node too, and that would be beacon URI. I think it's typically like, let's say 3500 for Lighthouse, and that's actually the default URI. So by default, it will use the local port 3500. Okay, that's good on the information. Anything else from here that we want to do? Not really so much. And I want still to add the useful ClickHouse queries here. Useful ClickHouse queries. So if ClickHouse local, you can query the combined file with like kind of SQL-like queries. And it's pretty amazing because the entries, they have like 10 million entries per day. And ClickHouse does such a query on like 2 seconds. That's pretty good. And there was one more thing I wanted to do. That is, yeah, exactly linked to the example. Where is that? Link to here, example output. Okay. Okay, that's a good start. Let's see here. I think it would be nice to go over the code real quick. So the entry point is a command. tnd service bitcollect.go. So if you start it from the CLI, it basically goes here. Let's see, CLI start bitcollect goes to bitcollect.go, and all that does is basically compiles the list of relays, and then it starts a new bit collector, which is this thing here. The bit collector is in services bitcollect bitcollector.go. That spawns the necessary collector threads, get header, data API, and ultrasound, and receives the per source specific data types through channels. So each of these data sources, they have their own data types, with like their own whatever format we get from them. And once any of these specific bits are received, we send it to the processor. This is a critical service. This is a separate thing here. So let's put this here. The processor, it's in bit processor.go. One important thing here in the collector is that we receive source specific bit types, and then we convert them to the common bit format. The common bit format is what is in the end stored in the CSV files, and this is this data structure here. It has these informations that are filled out as best as possible. They are deduplicated based on these key bits. So let's actually add this to the document. Bits are deduplicated based on this key. This means only the first bit per given key stored, even if, for instance, other relays also deliver the same bit. So basically currently, if like 5 relays return the same bit, the archive will only contain the first one that serves the response. And this relay will be stored as part of the bid, but it's not necessarily very authoritative because kind of like a microsecond later, the HTTP request of another relay could come back and this information is just lost currently. It could be a future improvement idea to either cache this and save multiple relays per bit, but it has its own problems because of the timestamps possibly. Or we could create a second table, which relays received which bit key at what point. Maybe let's add more note here. Okay, no, that's fine. And this type, the common bit type, this file has a few functions to convert ultrasound stream bits, data API bits, or get header bits to the common bit format, all with their specific conversations. For instance, let's see. For instance, the get header native response does not include a timestamp. So the timestamp that is going to be used there is the received at timestamp. And you can see this here. This is done on the CSV output. There are like any necessary like transformations and filling out things, like making sure we have the timestamp in milliseconds. If this field is not supplied, we take the bit timestamp and multiply it by 8000. And if the timestamp field is also not there, like on the get header bits, then we use the received at time. So it's like the timing of the get header bits is not that accurate because we only poll at one point and this time will be taken. But it's, I think, a best effort. Okay, I think that's like a rough overview. We should absolutely store this thing, this diagram in the repository. So let's see, project, flashbots, Relayscan, docs, images, bit collect, overview. Okay, I can link this here. How does this work? Let's bit collect overview. Let's see if that works. Yes. Okay, that is good. I think what I like, what is one missing piece here is that it's currently uploading the bits to Cloudflare R2 and S3, but we do not yet have a website showing it, like this one. And what I want to do now is I want to basically copy the code from Mempool Dumpster to generate this website. And yeah, let's do it. So let's make a git commit. There's one small hiccup. Push this. So now we want to make the website. Okay, so let's take a look at Mempool Dumpster. And what do we want from it? In Mempool Dumpster. Can I just open the other project here? What happens if I do that? It just switches. So let's do this. On the Mempool Dumpster, we do have the website thing, and I think we want most of this. So we need to think, where do we want to have this in our repository here? Services bit collect, maybe in there. Maybe try this out. Let's copy from Mempool Dumpster the website stuff into services bit collect. And then we do have one more thing. Is the dev server thing that Mempool Dumpster has. Okay, let's see. Let's take a look at the Mempool Dumpster main.go. What does it do? It can run a dev server, it can build the production output, it can upload the production output, and it has an output directory. I think we only want to start with this thing here and just do a dev server. And that's like the goal for now. So we have dev server here. Can we just... Why is this red? Okay, let's see if there's any issues. What do we need this for? Human 2 bytes. Okay. Let's see. Can we open this in github.dev? We definitely want this. Oh, okay. I see. Let's see. Let's change the scene that I hide everything, and then I can log in nicely. GitHub. 1 second. 2FA setup. This will only be a second. GitHub. Okay, and we are back. Maybe a bit bigger. Okay, this is Mempool Dumpster, and we have been in a website dev server here, and the HTML data actually is wanting these common is the human bytes, and this is using humanize, so I'm gonna install that for Relayscan. Okay, and I'm gonna copy this into the common tools. Where is a good place for this? Common utils, perfect. Yep, works. And we might just want to test the function as well here. Okay, good. Let's see. What else is an issue? Okay, that's all fine. And here we want to copy this, maybe I can delete the rest. So, a dev server. Can this just have a main function too? It's like a bit hacky, but let's see. Okay, we need a separate package, I think. So actually, what we're gonna do is I don't really want to make a new service, but maybe that's what we gotta do anyway. A bit collect, I don't want to modify that. But I just want something lightweight, either new bit collect dev server thing. Maybe that's the cleanest one. Maybe we should just add this here. Okay, let's do it like this. Run dev server. We put this bottom, that is because it's really not so important. Okay. And if this is actually set true, so dev server, and at this point we just want a function. Okay, we ignore this. Oh yeah, listen address. Let's say I'll put this here. Dev server, listen address. Just hardcode this for now. Website. Okay, this is correct. Logging is logros. I think we can just reuse log. This is not log roasted entry. Oh. This is using SEP. So we're definitely gonna want to change that to logros. And that should always be true. Ignore all that stuff. Okay, just simplify it. Dev server is starting. Starts the web server. Remove pprof for now. Remove the logging middleware. Gzip. I don't know if this is even needed. Probably not. Respawn error. This is from SEP to logros to change, so we filled error. We filled error. Okay, and that's it. Then we have handle root with the base template and then the monthly template. All right. Okay, that looks all correct because all the paths they match mempool dumpster. Let's just see if this runs really. Sorry, what? Oh, yeah, okay, right. Like, and we want dev server. Okay, starting a dev server. Let's see what port that was again. 8095. And it didn't find the template, which is fine because it uses the relative one, so we just need to change that. Let's see where do we define the templates? I think it's here, parse templates, and then it's like services, bid collect, and this one. I think that should be it. Oh, and the base templates too. All right, excellent. Let's make a git commit. Start the website. And now we change the template to have it say Relayscan Bid Archive first of all. And it's live reloading. Excellent. Relayscan. And that is really nice. So HTML data is our dummy data and some helpers for HTML template stuff. Let's see, here is some example entries, example months, example entries. And this is the typical file representation. It's the file name, the size, and the last change date. So we will call this top and all is the typical files we have here. Should probably need a reload. All right. Okay, I think that's actually all that is needed here. Index root. Okay. Because this is not in collaboration with anyone really. CCO license is great again. All right. I think that's it from now. I will simply make a script to automatically build this page, and then we have an index. Woohoo! Thanks everyone. Goodbye. See you soon.